Okay, so here we have to prove this identity, which is cosine of 2 theta divided by sine theta plus sine 2 theta over cosine theta is equal to cosecant theta. So here we have some double angles, we have some fractions, and we have some reciprocal identities. So here we go. First thing first, we want to start with the more complicated side, which you can see is the left side here. And we also want to, in general, we want to express everything in terms of sine and cosine. And we want to probably get rid of these 2 thetas, right? Because we want to show that this left side is equal to the right side. And on the right side, we don't have any 2 thetas or anything. So we want eventually, we're likely going to be using double angle identities. And also another thing, just I noticed off the bat, is that we're probably going to have to combine these 2 values, right? Because our end result has to be one value, or one term, I should say. And so we're probably going to be needing to combine these terms. It's kind of good to kind of observe what you need to do just even from the first step. So here we go. Left-hand side is equal to that. And we want to show that this is equal to the right-hand side using some algebraic manipulation. So first thing what I'm going to do is I'm going to combine the 2 fractions, like I said. So we want to find a common denominator, which in this case is sine theta times cosine theta. And so to combine them, I'm going to multiply this fraction, both numerator and denominator, by cosine theta. And this fraction, I'm going to multiply both numerator and denominator by sine theta, here and here. And so now, when we have the same denominators, we can just simply add their numerators together, right? And so there we go. This numerator plus this numerator, all over the same denominator. And now, here I made one observation, right? You might say, well, there are 3 different types of double angle identities for cosine 2 theta. So we don't really know which one we're going to use just yet. But keep in mind, back to our original equation here, cosecant of theta, right, is 1 over sine theta, right? It has sine theta in the denominator and 1 in the numerator. And so right here, we have sine theta and cosine theta. So we probably want to cancel out that cosine theta eventually, right? And so it makes sense, sine 2 theta, if I convert that using the double angle identity to 2 sine theta cosine theta, now this term has a cosine theta, this term has a cosine theta, and this term. And so all 3 we can just cancel out. So that's getting us closer, right? Again, you always want to keep in mind what your end result you want to be, which is 1 over sine theta or cosecant theta. So here we go. A lot of thetas, blah, blah, blah. So let's see what's going to happen. Here we're going to have 2, right? We're going to cancel cosine theta from all 3 terms. So here we have cosine 2 theta. Here we have 2 times sine theta times sine theta. So 2 sine squared theta. And again, in the denominator, we have sine theta. And again, we want to manipulate this, the numerator, so that it becomes 1 somehow. And so that gives us a clue that we want to use the cosine 2 theta is equal to 1 minus 2 sine squared theta, right? Because now the 2 sine squareds will cancel each other out, and we'll get our answer that we were looking for, which is 1 in the numerator, which is equal to cosecant theta, which is equal to the right-hand side. And so we've proved this identity. So one time again, right? First off, we notice that our end result has to be 1 term, so we're going to have to combine them together. And so we did that by finding a common denominator. And then we realized that our end result, we want to have 1 in the numerator and sine theta only in the denominator. And so we're trying to cancel this cosine theta. And so we use that double angle identity for sine 2 theta. And so now each term has a cosine. We can cancel it out. And now, again, we want our numerator to just be 1. And so we use the cosine 2 theta double angle identity that will allow that, right? We have negative 2 sine theta plus 2 sine theta. They'll cancel out, and we get the answer that we were looking for of 1 over sine theta or cosecant theta. So there we go. That's our final answer.